So this is part 2 of the chapter 4 exercise I'm going to talk to you about with it. There's a table that I would like to refer you to. Let me clear this right here for a second with it. And in here, besides the equal sign and the single equal sign, in the operator that we talked about, I just want to make you to be aware of that there is, all this time we're talking about relational operators in this thing. So just to make sure you understand, this is from, you got to know this. This is from table 4-1. So all these, besides the equal, and you have the not equal, meaning if you had something like an expression, I'm going to go through all these with you in a second here. We're familiar from algebra as lesser than, and there's also a lesser than equal to, and there's also a greater than, and there's also a greater than equal to. And all these, but all these you're familiar with it. Again, all these, they have to evaluate up to some sort of mathematical expression with it. So I covered this with you. Now let me talk to you about this one right here with it. So in the expression, for example, and if you think about it, I want you to think about if something that is, let's say I did 5 not equal to 5. Okay, again, this is the not equal sign with it. So what happens when this means with it? So if you think about what this is saying, with it, when you have a not equal with it. So let's say, if you think about, first of all, not to confuse you, is 5 equal to 5? It's true. And then if you flip the bit and you put it not equal, this becomes what? False. So the whole outcome on this is false with it as well. All right. So I want to clarify that if you gave this particular expression that you have with it, so this is false by flipping that bit with it. Again, if I have something that is, let me come over here a little bit more space with it. So if you have something like, for example, what is 4 not equal to 5? Okay. Again, let me rewrite this and how you were thinking about doing this with it. First of all, is 4 equal to 5? Well, it is false, right? Because 4 does not equal to 5. And again, this is totally, I'm treating this like an equal. So, which is false. But I put the bit in front of it, so this becomes what? Now true. I just flip it all the way around with it. All right. So that's kind of the way how you want to think about this with it as well. So just to practice some of the stuff that I want to clarify with you, what's going on with this as well. There is a little typo I want to point out on page that you don't. I want to point out on page 190. There's a typo that the book has. Go page 190, and down in the comparison character table with it, which is the ASCII table with it. And there's the ASCII value for number 43. That's supposed to be, the character is the plus. Okay. In the book it has a number 1. So the book has a number 1. This is the typo with it. The correct answer is this plus. There's a plus sign. All right. So that's just only typos that's in the book with it. So as you go through this chapter, I want you to take, for example, some of the exercise that I want to approach you to do with it as now with it. Like I said, just walk through the chapters with it. So, for example, one of the things that they're going to ask you is, which is greater? If you take the char character of an uppercase A, is this greater than or equal to? I'll pick a letter, a char character F with it. If you take an uppercase 65, what is that? Well, I'm sorry, if you take an uppercase A, the only one I know is 65, right, as a numeric value, is that greater than or equal to the letter F? Uppercase F is what? Is 70, all right, with it. So is this true or false? Well, 65 is less than 70, so this Boolean expression is false. Okay, so that's how that works with it. Okay, you kind of have to see how that works with it, and I play along with some of the stuff with it as you go through the chapters with it. I'm not going to dive in some more with it, but here's what I like to do. Let me pause the computer for a second, pause the video. I'm going to come in, I'm going to actually do some exercise in the back with you as well, okay? So next I want to talk to you about, so all that was considered as a set of what's called relational operators. The second set I want to talk to you about what's called logical operators, okay? So these logical operators are a little different, and don't be confused between what these operators do and what they're not with it. So the first set I want to talk to you about are the explanation means not. The second one means and. Ampersand, ampersand. This means and. And the next one, pipe, pipe. In Unix we call this pipe. If you look at the keyboard, my keyboard shows it is the shift backslash. Okay, right above your enter key on your right hand side, and there's a vertical line. So this is what's called an OR. Now, so these three sets of logical operators, this is actually table 4-1 from your book. Okay, if you look at table 4-2, I'm sorry, they're called your logical operators in here with it. So in your operator, as you're looking at this, so for example, if I say something that is not, you just flip the bit around. If it's true, true becomes false. That's all this is to say. That's what you're trying to do. So in certain expression, so if I said like 1 is greater than 0, all right, and this Boolean right here, it all comes to be what? A true, right? Because 1 is greater than 0. But if I put the bit in front of it, I've just flipped that in this parentheses, this outcome will be with this behind it. This will be false. Okay, you see how that works with it? Now, that's the easiest one. Let me talk to you about the other one, is the ands right here with it. And this is what's called, you hear what's called table of truth with it. So the table, here, let me go ahead and create a new one right now with it. So let's talk about the and, tables of and, the ands in here. All right, the ampersand, ampersand. That stands for the and expression with it. And I'm going to come over here. I want to do, I want to write expression. Do this here. Take this back here, sorry. I'm going to come up here to a little bit. Let's do the ampersand. And my Wacom tablet's not working. It's ampersand with it. All right. So it has, and this is the what's called the and. All right. So in here, I'm going to write expression. One, and then I'm going to write expression 2 in here. So if this is an and, okay, so this is if I have an ampersand in between them. If my first expression, I'm going to draw a line. Let me draw a line underneath this. If my first expression is a true, and my second expression is a true, the outcome would be, I'm going to write a column over here, it says outcome. And this outcome is going to be true. If my first expression is true, my second expression is false, this outcome would be false. Okay, so this is false, so this would be false. Sorry, let me kill my phone here. So if my next expression is true, false, let me come. My Wacom tablet's all messed up here. Let me use my mouse to be a lot easier. My pen is not working properly with it. If my next expression is false and this expression is true, my outcome would be false. If my next expression is a false and my last expression is a false, my next second, and this would be false. So here's what I'm trying to get at. In order to be a true outcome, which is this is the only one, if you look at this is the only one in this table of truth right here that I'm looking at, it's this one right here, is only truth with it. Both sides have to be truth. So let me ask you this. If my first expression is false, is there a need to even to look at the second expression? Because if the first expression is false, don't you agree that this is going to be false? Think about it a little bit. All right? I want you to think about this a little bit with it. All right. So that's the first part. Let me stop the video. This is the end of the video because we're coming down almost 12 minutes here. Let me stop this video before I pick up this the third part or the next part in this thing. Okay. So hold on.